All right, now I'm going to look at selected problems from chapter 3. Let's look at the vertex of a parabola and max-min problems. There's two objectives. One says find the vertex. One says find the vertex and the y-intercept. One says find the minimum or maximum value and where it occurs. The min or max of a parabola is going to occur at the vertex. So it just depends on whether your parabola opens down or whether it opens up. So let's first do vertex and y-intercept. That was what we needed to do when we were trying to graph a parabola. And for this example, let's do an equation that's in the vertex form. So let's look at this one, which is in the vertex form. Okay, so when you think about this one, it's already set up where I could just get the vertex right from that equation. But I have to remember that this is the vertex form. So the number that's following your minus sign is your h. Whatever it takes to make that 0 is your h. So your vertex is going to be hk. In this case, that would be 2, 5. Okay. All right. Now the y-intercept that's the vertex. The y-intercept is found like it is for any function. If it's a place where the graph crosses the y-axis, you know to let x equal 0 and just plug in a 0 where x is and solve that. So we have a 2, then 0 minus 2 quantity squared plus 5. So the y-intercept is going to be 2 times a negative 2 squared is positive 4 plus 5. We're going to get 8 plus 5 or 13. So that's the y-intercept right there. And that's the vertex. All right, let me just put one more of these on. Let's say you have negative 3x plus 1 squared minus 2, something like that. Okay, the vertex in that case would be negative 1, negative 2. See how the minus x minus h is going to be whatever it would be that would cause that to be equal to 0. So this would need to be a negative 1 to be equal to 0 inside those parentheses. And then see how the k is just whatever's following that. And k could be positive or negative. In this case, see the minus there? That means the k is a negative 2. So in this case, h is negative 1 and k is negative 2. So your vertex is negative 1, negative 2. Now they didn't ask me on this one, but on the first example I did, see how this 2 out in front is positive, so that parabola opens up? Then that would make the vertex a minimum, okay? And on this one, the parabola opens down, so in this one, that would make the vertex a maximum, okay? But I'll do the max-min with a parabola that's in y equals ax plus bx plus c form. So you oftentimes have them like this. So what if we had y equals negative x squared minus 4x plus 7, and they wanted it said find the minimum or maximum value and where it occurs. So when it's like that, to get the vertex, you're going to get it from negative b over 2a. That first part of the quadratic formula is the way to remember that. So that's going to be the x-coordinate of the vertex, and then once you have that, you can just plug it in to get the y-coordinate. So for the x-coordinate of the vertex, you're going to take the opposite of the b value, which is negative 4, over 2 times the a value, which is a negative 1, right? So the a is negative 1, the b is negative 4. So I work that out. I get positive 4 over negative 2, which is negative 2. All right, so that's the x-coordinate of the vertex. To get the y, I just plug that in. Negative 2 is going in place of the x in both spots. And then you got to watch how you simplify this first term. The squaring happens first and gives you a positive 4 there, but you still have this minus out in front. So it's negative 4. And then a negative times a negative is plus 8, and then plus 7. So we wind up with 4 plus 7, which is 11. That's the y-coordinate of the vertex. Okay? So now we need to think about this. So this particular parabola, is opening down because the a value is negative. That negative 211 is this spot right here, okay? And so the way the objective is worded sounds like they want you to understand that this means we have a maximum value of 11, and it occurs at an x equals negative 2. So the y-coordinate is actually the max. Sometimes it's the min, but in this case it's the max. And then where it occurs is at x equals negative 2. All right, next one I want to do is zeros of the function and determining if the graph crosses the x or y. All right, so let me go to a good example there. So this was find zeros of the function, determine at each if the graph crosses the x-axis or touches and turns. All right, so that would be like if you had a problem where it was given to you in factored form, like maybe you had something like negative 3, x minus, let me put another x out here because that's tricky. Like negative 3 with an x, and then an x minus 2 maybe to the second power, and then maybe x plus 4, and that's to the third power. Okay, and this is your function. All right, so this objective says find the zeros and then determine if the graph crosses the x or touches the x-axis and turns around. All right, so for that, if I'm looking for the zeros of the function, I'm looking for what would cause this to equal 0. And usually my job is to get things factored, but they've done that for me. So now I can just take each of these factors and set them equal to 0. So it boils down to either x would have to be 0, x would have to be 2, or x would have to be negative 4. Those are the zeros. Now what you want to do is pay attention to the exponent on those zeros. So the x is just to the first power. The factor associated with a 0 of 2 has an exponent of 2. And then the factor x plus 4 has an exponent of 3. So this is going to pass through like a line. This one's going to touch and turn, and this one's going to pass through like a cubic. So it still crosses the x-axis. So the 0 would be 0, and it would cross. Okay. And then 2 would be a 0, and it would touch and turn. And then the 3 is going to be a 0, and it's going to cross, but it just flattens as it does so. Okay. All right, and then there was a previous objective on end behavior. I can touch on that here. This is the issue of multiplicity, like what the exponent, how many times your factor occurs, what the exponent on the factors would be. That's what determines the behavior at the zeros. But if I were to multiply out this function and get the leading term, then it would turn out to be a negative 3x to the 1, 2, 3, 4, 5, 6 to the 6th power, and then there'd be a bunch of other stuff. But if I were doing end behavior, that's all I would need. So for this one, for the end behavior of this one, it's an even number, so the arms are going to be in the same direction, and they're going to both point down. So it's going to be down to the left and down to the right because it's negative. So it's going to behave like a upside down parabola. Okay. All right, another one asked you to divide polynomials using long division. I've done a whole video on that one, so I don't think I'll do that again. Just go look at the video on long division that I did earlier. Let me go to the one that asks you to find the zeros of a polynomial. Okay, so this one's going to ask you to find the zeros, but it's not in factored form, and it's not easy to get it in factored form. So that would be a problem like this. Like f of x equals x to the third minus 7x squared plus 13x minus 3. You know, sometimes you can factor these by grouping to get them in factored form, but this one wouldn't do it. So the whole process for this required us to find the possible rational zeros. So the ones that are positive or negative, some relatively nice thing. It can be fractional, but it can't have radicals or anything like that in it. So that comes from the factors of the constant term, so the factors of 3 divided by the factors of the leading coefficient, which would be the 1. So factors of 3 are just 1 or 3, positive or negative, and the factors of 1 are just positive or negative 1. All right, so here's where you make your list of possibilities. So in this case, our list of possibilities is a 1, a negative 1, a 3, or a negative 3. Now, if this had been a 2 down here, then we would have had, you know, positive or negative 1, positive or negative 2. We would have had more. We would have had a 1 and a 1/2, a 3 and a 3/2. But we didn't have that. We just had positive or negative 1. So these are the possible nice ones. This is a cubic, so we need one of those to work to be a zero of the polynomial, and then we'll be able to use it to get that broken down to where we have just a quadratic function left. So here's where on scratch paper, you're going to do one of these on the take-home test. On scratch paper, you would do the testing. So you just kind of go through these until you find one that works, meaning here at the end, we want the remainder to be 0. So we're actually using synthetic division to determine if 1 is a 0 of the function. So you always bring down the first number, then you multiply and write it in the second column. Negative 7 plus 1 would be negative 6. 1 times negative 6 is negative 6. 13 plus a negative 6 is 7. 1 times 7, okay, nope. So 1 is not a 0. So then you go and you try negative 1. 1, negative 7, 13, negative 3. Those come from the coefficients. Those numbers, remember, come from the coefficients of your terms originally. Okay, and then you're going to do the process again. So bring down the 1, then you'd have a negative 1 there. Then we'd get a positive 8. I can already tell this isn't going to work, so I don't need to continue. So that one's not going to wind up giving me a remainder of 0. So I'm going to move on. Now I'm going to try 3. Okay, so I'm going to bring down the first number, multiply, add straight down. So I multiplied, now I'm adding straight down. 3 times negative 4, add straight down. 3 times 1. Okay, here we go. We got a remainder of 0. And notice we have just 3 numbers left here. This is your A, your B, and your C. What you've really got is that original polynomial, you don't have to write that this is what happened, but this is what happened. The 3 corresponds to the factor x minus 3, and the other factor would be x squared minus 4x plus 1, coming from these numbers here, okay? So that's the idea behind it. You don't actually write that, but you know, we're looking for where that equals 0. So we know 3 is one of the zeros, and then the other one is going to come from solving that quadratic. So that's why at this point, you don't keep testing, okay? You just go and you look at solving what causes x squared minus 4x plus 1 to equal 0. So first try factoring, but this one won't factor. Okay, when we try to factor this one, we know the 1s won't work, and that's the only possibility. So we'll go in and use the quadratic formula, and you need to know that. opposite of b plus or minus square root of the b, make sure it's in parentheses getting squared. This first part is always going to be positive. Then minus 4 times the a value times the c value. And all of that's over 2 times a. And then you just work it out. Opposite of negative 4 is 4. Opposite of 4 squared is 16. Here we just have one negative, so it's going to be minus something, and it's minus 4 all over 2. So we've got 4 plus or minus the square root of 12 over 2. We need to simplify that. So we're going to break up 12. To do the square root of 12, we can do the square root of 4 times the square root of 3, and the square root of 4 is 2. So right here where the square root of 12 was, I'm going to put that 2 square root of 3 right there. So we have 4 plus or minus 2 square root of 3 over 2. And then since 2 goes into both 4 and 2, you would simplify further and say this is 2 plus or minus the square root of 3. And that would be your answer, those two solutions. 2 plus the square root of 3 and 2 minus the square root of 3. Okay? So don't simplify here. Don't divide by 2 at that point, right? So if you had a problem, let me get some more paper before I run out. Yeah, good. Okay, so say what if you wound up with, let me make it a 6 plus square root of 2 over 3. That's fully simplified. Even though 3 goes into 6 evenly, it doesn't go into the 1 there, and so you would just leave it. You would just leave it 6 plus the square root of 2 all divided by 3. You can't just divide 3 here and here. It would have to go into the entire numerator. The reason that other one works is 2 is literally a factor of the whole numerator, and so then that 2 can be canceled out. Okay? There's a lot of problems with simplifying those kinds of things.